In September 2020, the MIPI Alliance announced the release of the new A-PHY specification, the first industry-standard long-reach SerDes physical layer interface supported by leading companies in the automotive ecosystem. The new specification provides a robust multi-gigabit asymmetric data link, providing high-speed unidirectional data, embedded bidirectional control data, and optional power delivery over a single cable. A-PHY Spec 1.0 offers a near-zero packet error rate of 10 to the minus 19 for unprecedented performance over the vehicle lifetime, unprecedented immunity to EMC effects in demanding automotive conditions, cable reach up to 15 meters long with up to 4 inline connectors, and data rates as high as 16 gigabits per second with a roadmap to 48 gigabit per second and beyond. A-PHY brings many additional benefits to OEMs and Tier 1s, including rapid system integration, minimal need for software development, a fast EMC test route from ECU to in-vehicle testing, and no need to manually tune the chipsets to the properties of the cable, which guarantees superior link performance over time. Valens chips supporting native CSI2 extension over MIPI A-PHY are currently in development. And as part of this process, we have taken an existing Valens automotive PHY paired with an FPGA to implement CSI2 interface extension. For the demo, we have created a proof of concept sensor module shown here, which includes 1 or 2 8-megapixel CSI2 sensors. The sensor module supports the various requirements of the new MIPI A-PHY standard, including CSI2 tunneling, an I2C control back channel, and GPIOs for services including FrameSync. The Valens automotive chip in the module has 2 PHYs, each running at 4 gigabits per second, yielding a total bandwidth of 8 gigabit per second over 2 UTP cables with unshielded multi-gigabit automotive connectors. Alternatively, the link can run at 4 gigabit per second over a single coax cable. The cables themselves can be up to 15 meters long with up to 4 inline connectors. Actual MIPI A-PHY devices will be used with shielded pair or coax cables and will support 8 gigabits per second on a single cable. In addition, Valens A-PHY chipsets will be capable of supporting link speeds of up to 4 gigabit per second over an unshielded twisted pair cable. On the far side of the link, the packets received are converted back to a native CSI2 data stream, which is output to an SoC connected to the monitor. On the screen, we can see the image received from the sensor, as well as its configuration settings. Thanks to our adaptive noise cancellation and ultra-fast PHY-level packet error correction, Valens automotive technology guarantees that all packets are delivered error-free across the link, even under the harshest of automotive EMI conditions, with a link latency of only a few microseconds. The inherent robustness of our devices also means that they can cope with cable stresses, bending, aging, and shield impairments that lead to deterioration of the cable quality parameters and which could otherwise lead to link performance issues and even link failure. While this proof of concept demonstration utilizes Valens automotive PHYs, it provides an insight into the capabilities of our upcoming MIPI A-PHY devices. As mentioned, we are already designing our first A-PHY chipsets that will enable the extension of CSI2 over a single wire pair or coax running at speeds of up to 8 gigabits per second. Our upcoming VA7031 device will be a CSI2 serializer over an 8 gigabit per second A-PHY link, and our VA7044 chip will be a quad A-PHY receiver with 4 8 gigabit per second links, deserializing to 2 CSI2 outputs, both supporting up to 16 CSI2 virtual channels. The VA7044 will also have a CSI2 input to enable the creation of advanced sensor topologies. Our VA7042 A-PHY receiver chip will be similar to the VA7044, but will support 2 rather than 4 8 gigabit per second A-PHY links. MIPI A-PHY solutions are designed to meet the needs of future AD card networks, supporting complex topologies, high bandwidth, and strict safety requirements. Engineering samples of our VA7031, VA7044, and VA7042 A-PHY solutions will be available mid-2021. I invite you to view the additional video snippets for more information on the many features that will be supported in our new A-PHY chipsets.